Hello, welcome to my YouTube channel. My name is Irfan and today I'm going to show you an overview of machine learning and different types of machine learning. So let's get started. So let's first have an overview of machine learning. So machine learning is a subfield of AI. In machine learning, machines learn from data without being explicit programming. For example, in the diagrams shown here, the one is traditional learning. In traditional learning, we give the data and rules to the machine and machines provide the answers. But in machine learning, we give the data and answers and the machine define its rules to learn from this data. Now let's talk about different types of machine learning. There are three different types of machine learning: supervised, unsupervised, and reinforcement learning. Let's first have a look on supervised learning. So in supervised learning, we have the labeled data, which means the desired output is known. So we provide the machine with the pairs of inputs and desired outputs, and the machine learns to produce the desired output given an input. It is called supervised because it's like a teacher provides supervision to the students. Let's try to understand through an example. For example, we want to classify the emails, whether the email is spam or not. So we provide the machine with the inputs of the email data and outputs as well, which email is spam and which email is not spam. So machine learns from this data and define its rules. So when a new email arrives to the machine, it can classify whether it is spam or not. We can solve two different types of the problems with supervised machine learning: regression problems and classification problems. In regression problems, the output variable is real or continuous value. For example, if you want to predict the salary of the person, it's a regression problem. In classification problems, the output variable is categorical with two or more different classes. For example, if you want to classify whether the incoming email is spam or not, it's a classification problem. For regression problems, we have a number of algorithms available. For example, we have simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision tree regression, and random forest regression. For classification problems, we have logistic regression, support vector machines, k-nearest neighbors, decision tree classifier, random forest classifier, and naive-bayes classifier. Unsupervised learning. So in unsupervised learning, we have unlabeled data. That is, the desired output is not known. So we only provide the input data to the machine. It is called unsupervised because no supervision is provided. It's like learning without a teacher. And the main idea of unsupervised learning is to find hidden patterns in the data. For example, if we take our previous examples of the email, so here we only provide the input data of the emails, but we do not specify which email is spam and which email is not spam. So machine learns from this data and find the hidden patterns inside the data. So it will divide this data into two different groups. And from these two groups, we can easily identify which email is spam and which email is not spam. And you will be wondering, what are the applications of unsupervised learning? It can be used for customer segmentation with similar preferences. Let's try to take a practical example. Suppose a telecommunication company have the data of the customers, the call duration and internet usage. So they feed this data to the machine, and the machine finds the hidden patterns in the data and divide the data into three different groups: Group A, Group B, and Group C. On the x-axis, we have call duration, and on the y-axis, we have internet usage. From these three different groups, we can easily recognize the Group A customer, they have high call duration and high internet usage. For Group B customers, they have high internet usage and low call duration. And for Group C customers, they have high call duration and less internet usage. So based on this information, the company can provide different packages to the customers in Group A, Group B, and Group C. For example, Group B customer, they can be given cheaper data plans. Group C customers, they can be given cheaper call rates. And the Group A, they can be given both benefits. Unsupervised learning can be further divided into two categories. So we can solve clustering problems and association problems using unsupervised learning. So in clustering problems, we divide the input data into different groups based on similar properties. For example, in our previous example of the customers for telecommunication companies, we can divide the customers into three different groups. Association problems. In association problems, we try to link one variable with another variable. For example, if a customer is buying a cake and we assume that he might be interested to buy a chocolate or maple syrup. For clustering problems, we have k-means clustering, hierarchical clustering, and db-scan algorithms. For association problems, we have a priori algorithm and ECLAT algorithm. Reinforcement learning. Reinforcement learning is a bit different. It is based on the reward system. Here, the objective is to maximize the reward. The machine learns to perform an action from experience. It's like learning to ride a bicycle. you fall, you learn from your mistakes, and then you try not to repeat that mistake. Let's take an example of a self-driving car. A self-driving car is an example of reinforcement learning. The car acts like an agent. It takes an action in the environment and gets two feedbacks, the state and the reward. State is the current state of the environment, and reward can be positive or negative based on the action of the agent. Now the question is how to decide when the reward is positive and when the reward is negative. Let's try to understand through an example. For example, we assign the self-driving car to move from point A to point B. If the car takes any action to move toward point B, then it will get a positive reward. And if it takes any action to go away from point B, it will get a negative reward. So based on this reward, the car will be able to learn from its mistakes and not to repeat those mistakes. Reinforcement learning can have two different types: model-free reinforcement learning and model-based reinforcement learning. In model-free reinforcement learning, we do not make any assumptions about the environment. It's about learning from trial and errors. For example, training a computer to play a chess game. In model-based reinforcement learning, we make assumptions about the environment, build a model of the environment, then uses that model to determine the best actions. For example, a self-driving car. For model-free learning, we have different algorithms like Q-learning, SARSA, state action, reward, state action, deep Q networks, policy gradients. And for model-based reinforcement learning, we have DynaQ, Monte Carlo, tree search. So in this video, we talk about different types of the machine learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we have labeled data. In unsupervised learning, we have unlabeled data. And in reinforcement learning, it is based on reward system. So that's a wrap for today's video. Hopefully you enjoy the video. Remember to hit the like button if you find this helpful, and subscribe for more clear and concise explanations. Until next time, enjoy machine learning.